In preview activity 3.5, we have a spherical balloon being inflated at a constant rate of 20 cubic inches per second. How fast is the radius of the balloon changing at the instant the balloon's diameter is 12 inches? And then we're going to answer the question, is the radius changing more rapidly when d is 12 or d is 16, and why? So we have a related rates problem, and in part B, what we see is that we are asked to use the formula for the volume of a sphere, V equals 4/3 pi r cubed, and use this to get basically a relationship between the rate that the volume is changing and the rate that the radius is changing. So what we're going to do is differentiate each side with respect to t. Well, the derivative of v is just 1 dv dt, because we have to think of it as a chain rule. We're thinking of v as a function of t, so we could write its derivative as dv dt. Now, over here, we're going to have another chain rule because we're thinking of r as a function of t, so this is a composition. So first off, we're going to do the derivative of the outside, so that's 4/3 pi is a constant, it stays out front. We bring the 3 down, r, decrease the exponent by 1. That's our power rule. Now we take the derivative of the inside, so the derivative of r with respect to t is dr dt. And we now have a relationship between the rates. We can do a step of simplification here and write it as 4 pi r squared dr dt. Now, what they're doing is they're giving us the fact that it's being inflated at a constant rate of 20 cubic inches per second. Well, what that is the rate that the volume is changing. So for part C, we know that our dv dt in this situation is 20. And it's in cubic inches per second. So a couple ways we know it. It's being inflated, so this is a change in volume. Also look at the units, cubic inches. So now what we're going to do is use this to figure out how fast the radius is changing. In other words, find dr dt when d is 6 and when d is 16. Well, remember, we need r, or we have r in our formula. So if d is 12, for instance, then r is 6. So let's see what we have here. Putting this into our formula, we know that 20 equals 4 pi r squared dr dt, and we want to solve for dr dt, so dr dt equals 20 over 4 pi r squared. So now we can do this when r equals 6. So dr dt when r equals 6, plugging 6 in for this is going to give you roughly, well, first off, let's go ahead and figure it out exactly. It's going to be 20 over 144 pi, which is about 0.044 inches per second. Okay, the reason for those units is it's a change in radius. Radius is going to be measured in inches, and our volume is changing per second, so our radius will be changing per second. So that's how we know the units. Now, something to notice in part E, notice our dr dt. Dr dt, like we said, is 20 over 4 pi r squared. So the larger r gets, the smaller dr dt gets. So if we wanted to compare at a diameter of 12 versus a diameter of 16, which would be a radius of 8, we would expect to see, a smaller value of dr dt. And it turns out when you plug in 8, dr dt is 20 over 256 pi, or about 0.0249 inches per second. And if we put in a larger radius, we would see it get even smaller.